All right, so today we're going to take a deep dive into the world of Albert Einstein.
Oh, interesting.
Now, I'm pretty sure, everyone listening has heard of Imskutel and, probably seen that famous picture of him, the hair, the crazy hair and all.
Yeah.
But there is so much more to him than just that kind of, genius scientist persona, right? We've got a ton of sources here covering like his whole life.
Wow.
And I'm really hoping that we can, uncover the person behind all that science.
Okay.
And, kind of get past the textbook version that we all kind of, grew up with and really see what made him tick. You know what I mean?
Yeah, yeah.
And what's really interesting is like one of the first things that we got to do is bust this myth, right?
Right.
That Einstein was a bad student.
Oh, really?
Which is totally not true.
That's so interesting.
Right.
Because he was like the opposite when it came to like the stuff that he actually cared about.
Really? So the whole like struggling student turned genius thing, it's just not true.
It's a big myth.
That's so interesting because I feel like, for a lot of us who, maybe didn't ace every subject in school, it's like this comforting story, right?
Totally.
But it turns out it's not even true.
Yeah.
So tell me more about that. Like, what's the reality there?
Okay, so imagine, this is 1879, Germany.
Okay.
Little Albert Einstein is born.
Okay.
And, he excels in math and physics really early on.
Like, not even just like keeping up, but...
No, like way beyond like thriving.
Really?
The challenge for him wasn't even like understanding the material.
Oh, wow.
It was more the structure, of traditional schooling, that kind of...
Oh, I see.
Yeah, it wasn't a good fit.
So it's almost like you're trying to make like a river flow in a straight line, right?
Well,
like sometimes these powerful minds just don't fit in those
That don't work, no.
predefined boxes.
It doesn't work.
Which I think is like a recurring theme that we see, right?
That's absolutely.
Like throughout history, right? With a lot of these brilliant minds.
Totally.
Not fitting into that conventional system.
Yep.
Which leads us to 1905.
Yeah.
Einstein, he's working as a patent clerk.
Mm-hmm.
And in his spare time, publishes F4 groundbreaking papers.
Amazing. Yeah.
Like F4. Yeah. It's insane.
It's crazy.
Was he just like revolutionizing physics before lunch or something?
I know. It's insane. Like mind-boggling when you think about how deep these papers were, like one of them, his theory of special relativity.
Oh.
It just like transformed how we understand space and time.
Okay.
Like showing that they're not absolute, but like intertwined in this like crazy cosmic dance.
Okay. Even I need a second to like wrap my brain around that one.
Yeah.
So, 1905 becomes this miracle year for Einstein.
It really does.
Right. Where he's like just reshaping the entire landscape of physics.
Absolutely.
Okay. So special relativity. What else is on this like scientific hit list?
Well, there's also the photoelectric effect.
Yeah.
This one actually won him the Nobel Prize in 1921.
Wow.
And so what he figured out was that like light doesn't just act like a wave. It can also act as like these particles called photons.
Oh.
And those photons can actually knock electrons off of metal.
Okay.
It's like tiny billiards, you know what I mean? And this was revolutionary because like this is what led to quantum mechanics.
So light is like a particle and a wave. It's already bending my mind a little bit.
Yeah.
And this is just the beginning of the miracle year.
I know.
Okay, what else is on this list?
All right, so Brownian motion.
Okay.
You know how dust particles like dance in a beam of sunlight?
Yeah.
Yeah, so he like provided the math to explain that.
Okay.
Proving that those tiny particles are like constantly being jostled by even tinier invisible molecules, which wasn't just like some theoretical thing. It actually proved that like atoms and molecules exist.
So he's like not only revolutionizing physics, but also settling like these big scientific arguments like on the side in his spare time. It's almost unfair.
I know, right?
Okay, and then there's the big one.
Okay.
EMS 8.
Yes.
Like it's like the equation, right?
Everyone knows it.
Everyone knows it, even if
they don't like get it.
They don't understand it. Like it's so simple but so complex.
It really is like what it's saying is that mass and energy are like two sides of the same coin.
Okay.
They can like be converted into each other. And that releases a ton of energy.
Okay, now that is like powerful.
Yeah.
Okay.
Yeah.
But I gotta admit, it still feels a little bit like magic to me, Like I need something like a little more concrete to really grasp like what it actually means.
So think about it this way. That equation is the basis for things like, nuclear energy.
Oh, wow.
Like the potential for weapons.
Yeah.
But also like generating electricity.
Right.
And like how stars shine, they're producing so much energy
Right.
through nuclear fusion.
So it's not just theoretical, it's literally like powering some of the most powerful forces in the universe.
Exactly. Wow, that like puts it into perspective.
Yeah.
But here's what I find really compelling about Einstein is like he wasn't content to just stay in that world of like theoretical physics, right?
Yeah.
He understood like what his work actually meant in the real world.
Yes.
And he used his platform to, speak up for causes that he believed in.
That's so important and like a part of his legacy that a lot of people don't know about.
Yeah.
He was such a powerful advocate for peace,
Yeah.
civil rights, and Zionism.
Now, I think, for some of us who may not be as familiar,
Yeah.
can you explain like what Zionism is? Sure. So basically, it's the movement for the establishment of a Jewish state
Okay.
in their ancestral homeland, which is now Israel.
Okay.
So Einstein, being Jewish, was a huge supporter of that movement,
Okay.
especially like with anti-Semitism rising in Europe.
Right.
He really felt that a Jewish homeland was super important
Yeah.
for the safety and cultural preservation.
Wow. So it wasn't just like these abstract intellectual things for him.
No, not at all.
He saw science as like deeply connected
Yes.
to like with the human condition, right? And he wasn't afraid to like use his voice
To speak up.
and like fight injustice
Yeah.
and advocate for like a better world,
Totally.
He
really like used his power for good.
And that's such a good example of how like one person can actually make a difference.
100%.
But I'm kind of curious, like what happened after all this? Like,
Yeah.
did he ever like slow down
Yeah.
or was his mind just like always
Oh, always churning.
and like wanting to explore more?
Yeah. Oh, he never slowed down.
Okay.
So like life took a turn for him in 1933, with the Nazis.
Oh, right. Yeah.
Being Jewish and speaking out against like nationalism.
Yeah.
Yeah. It got dangerous for him.
Right.
So he ends up, coming to the U.S.
So even after all those incredible breakthroughs, he still had to like flee his home
I know.
because of like all that
Yeah.
awful stuff going on.
Because of intolerance and persecution.
It's kind of like a reminder that, even geniuses aren't immune
No.
to like all that turmoil.
No, they're
Yeah,
not.
what's going on?
Yeah. So he found refuge at Princeton.
Okay.
And he kept researching
Wow.
until he died in 55.
Wow. And is that where we start to see like another dimension to like his intellectual journey?
Absolutely.
Okay, I'm all ears. Like, what was he exploring during that time?
Okay. So he's still going deep into the cosmos.
Yeah.
But his focus also kind of shifts to this like quest for a unified field theory.
Oh.
He was basically trying to find like one framework
Yeah.
to explain all the forces of nature.
Wow. So he was like trying to find
The theory of everything.
the theory of everything,
Yes.
even after like all that he had already accomplished.
Oh, he never stopped.
It's like mind blowing, that level
Like,
of
put it on-
dedication.
It's like the curiosity just
Yeah.
drove him his
Yeah.
whole life.
And during that time at Princeton,
Mm-hmm.
he also like starts to kind of
Yeah.
become critical of some of the interpretations of quantum mechanics.
Yeah, he gets like a little hesitant.
Wait, hold on.
Yeah.
But didn't he like help lay the groundwork for quantum mechanics
He did, yeah.
with his work on the photoelectric effect?
He did, yeah.
So why would he be critical of it later on?
Yeah, that's where things get really interesting.
Okay.
So remember how we talked about quantum mechanics, like bringing in chance
Yes.
and probability?
Mhm.
So it's like saying that, on that small level,
Yeah.
things aren't as predictable,
Right.
as we might think.
Right.
It's not playing by the same rules as our like everyday experiences.
I can see how that might be hard to like swallow for someone like Einstein, right?
Totally.
Who spent his whole life like trying to find like those equations, those universal laws.
Yeah.
And it's like now you're saying that the universe is like playing dice with reality.
Yeah.
And that didn't sit well with him.
Yeah. He famously said, like, God does not play dice. He believed in order and like cause and effect.
Yeah.
And quantum mechanics was like this
wrench in the system.
Yeah. It challenged that whole belief system.
But wasn't that kind of like an outdated view even in his own time?
It was definitely causing some, like, debates.
Oh, okay.
You know, other physicists like Niels Bohr, you know, he was saying that we just have to, like, accept this uncertainty.
Okay.
That it's part of how the universe works.
Right.
Like, at that level, it's just probability and chance. It's not just us, like, not knowing enough.
Gotcha.
You know?
Yeah, I'm trying to picture, like, these intellectual giants just, like, going at it.
Oh, yeah.
Debating the nature of reality.
Oh, intense.
It must have been quite the show.
It would have been great to be a fly on the wall for those conversations.
So what were some of the specific objections that, like, Einstein was raising? Like, what about?
So one of the big ones was this thing called quantum entanglement.
Oh, okay.
Have you heard of this?
I've heard of it. I don't really understand it.
So basically you have two particles.
Okay.
And they're, like, linked.
Yeah.
No matter how far apart they are.
Yeah.
And you do something to one.
Yeah.
It instantly affects the other one.
Like spooky action at a distance.
Exactly. That's what he called it.
Yeah. I've heard that.
And he saw that as, like, you know, breaking the rules of his theory of special relativity.
Yeah.
Which says nothing can go faster than light.
Right. Right.
So to him, this was like a contradiction.
Oh, I see.
In the universe.
He was like, there's got to be something else going on.
Yes. He thought there must be, like, some hidden thing,
right.
You know, some variable that we just don't get yet.
Yeah.
That would explain it.
And that wouldn't, like, break the rules living.
Yeah, without, like, chance and randomness.
Okay.
You know?
So even though he didn't agree with some parts of it, he was still, like...
He's still trying.
Trying to engage with it and trying to understand it.
He was searching for a deeper answer.
Which is, like, I think so admirable about him.
Yeah.
You know, it's not about being right. It's about, like, challenging those views.
Exactly.
And pushing yourself to understand better.
Absolutely. That's like the definition of a scientist.
Totally.
You know?
Yeah.
It's not about being right or wrong.
Right.
It's about questioning and exploring, you know?
And even though, like, his ideas weren't widely accepted, the fact that he was, like, pushing back on those ideas helped to shape, like, the conversation.
Oh, absolutely.
And push the field forward.
It pushed everyone to do better.
So even in disagreeing, he was still, like, leaving a mark
100%
on that field.
Yeah.
But let's, like, switch gears a little bit and talk about, like, the other thing that he was working on at Princeton, which is, like, this quest
for
unified field theory. It sounds so ambitious.
It was.
Like, it's almost like looking for, like, the holy grail of physics.
Totally.
Yeah.
Yeah, he was basically trying to find this one framework to, like, explain all the forces, right? Gravity, electromagnetism, all of them, like, connected in one unified field.
Yeah. Okay. This is where, like, I start to feel my brain, like, reaching its limits.
It's a big concept.
It's a big concept. I'm trying to, like, picture it, you know? But it's just, like, shadows.
No, it's hard.
You know what I mean?
Yeah, it's hard.
And even though he didn't actually find it, he, like, laid the groundwork.
He laid the groundwork.
Right, for people to keep going with that search.
Yes.
Which I think is, like, really powerful.
It really is.
So even his unfinished projects are, like, still shaping, you know, our understanding.
It's like planting seeds that keep growing.
Yeah, he's not just, like, finding answers. He's asking the right questions.
Exactly.
That's, like, a much bigger legacy than, like, any one discovery.
100%.
You know, and we can't forget about, like, his influence beyond science, too.
Right, absolutely.
Right, like we were talking about earlier, like, advocating for peace and and all of that.
Yeah, he saw the connection between science and humanity.
Yes.
You know.
And speaking of which,
didn't
he play a role
He did.
in, like, alerting the president about, like,
about the bomb.
The atomic bomb.
Yeah.
Like, how did that happen?
So it's 1939.
Okay.
And he's getting worried about nuclear physics.
Okay.
Like, moving too fast.
Yeah.
And the Nazis, you know, possibly making a bomb.
Right.
So he signs this letter with other physicists.
Okay.
Urging President Roosevelt to, you know, start researching nuclear energy.
So he wasn't, like, directly involved with the Manhattan Project or anything.
No.
But he did help, like, get it.
He was part of the initial push.
Started, which I'm sure, like, he later...
It weighed on him.
Yeah.
You know, seeing the devastation of atomic weapons.
And that's like a reminder that even like the pursuit of knowledge can have like these unintended consequences. So we always have to be mindful of that.
Yeah.
Right?
Yeah, we have to think about the ethics.
Totally.
Use our voices for good.
Okay, we've covered so much, from quantum mechanics to like the unified field theory.
No, it's a lot.
To ethics. But there's one thing I still want to explore.
Okay.
Which is like his lasting legacy.
Yes.
Like, how is his work still shaping our world?
Oh, that's a good question.
Beyond those textbooks, it's one thing to like acknowledge that he was a genius.
Yeah.
But, like, how does it actually affect us?
How does it actually impact us?
In the 21st century.
It's everywhere.
His
fingerprints are everywhere.
Okay, I'm intrigued. Like, give me some examples.
Okay, so, like, think about GPS.
Okay.
You use that all the time, right?
All the time.
Those little blue dots guiding you, they rely on super precise timekeeping from satellites.
Yep.
And those calculations, they have to use relativity. Special and general relativity.
So Einstein's theories about space and time are like literally why GPS works.
It's true.
That's mind-blowing.
I know. If we didn't adjust for that, the timing from the satellites would be off.
Oh, wow.
And your GPS would be like miles off.
So next time I'm trying to find like a new restaurant, I can thank Einstein for getting me there on time.
Yes.
That's insane. Okay, what else?
Okay, so closer to home. Digital cameras.
Okay.
Solar panels.
Okay.
Both rely on the photoelectric effect.
Right.
Which he won the Nobel Prize for.
Yeah.
Remember, light is waves and particles.
Yeah, the photons.
Yeah, photons. So in cameras, those photons hit a sensor.
Okay.
And they release electrons.
Okay.
Which create the signal for the image.
Wow.
And in solar panels, those photons knock electrons loose.
Yeah.
And that generates electricity.
So he's not just explaining the universe.
No.
He's like powering our lives.
Yeah.
It's insane.
It's amazing.
There's got to be so many more examples.
Right. Think about lasers.
Okay.
From scanners to like medical stuff or like nuclear energy.
Right.
Which, it's complicated, but it wouldn't exist without immensity and like cosmology, black holes, the expansion of the universe, all of that.
Yeah, it's clear that it's so much bigger than any one discovery or equation.
It's like a way of thinking.
Yeah.
Yeah.
It's like a commitment to curiosity.
Yeah.
To challenging ideas.
Absolutely.
Which I think is so important, especially today, right?
Yeah.
As the world gets like more complex.
Totally.
And it's not something that he did alone, right?
Oh, no.
He was a part of a community of scientists, right?
100%.
Building on what came before.
Yeah.
And inspiring others to come after.
Exactly.
So as we kind of wrap up this part of our deep dive, I think it's like really important to remember.
What do you think the takeaway is?
That like Einstein's legacy is so much more than just like the science.
Totally.
Right? It's about like this way of thinking.
Yeah, way of life.
This commitment to curiosity and challenging ideas.
Keep asking questions.
Yeah.
That's how we move forward.
It's how we move forward as people and like as a society.
100%.
Okay, I think we've done a good job.
We did.
Of exploring like all these different facets, right?
Of his life.
Of his life and his work.
Yeah.
From like those really complex equations to those ethical dilemmas, right?
Yeah.
And the impact he's had on the world.
Probably.
So I hope you've come away from this like with a better understanding of the man, not just like the icon, and maybe a little bit inspired to like embrace your own curiosity and keep exploring the universe. That's what he would want.
Yeah. And if you ever get lost, just ask Einstein.
Or your GPS.
Right, exactly.
Yeah.
And don't forget to check out the show notes for more resources and explorations.
We'll have all the cool stuff linked.
Yeah, related to like all the stuff we talked about.
Yeah, absolutely.
All right, thanks for joining us.
Thanks for listening.
On this incredible journey.
Yeah.
And until next time, stay curious.
Bye. Bye.
Okay, so we're back, and we're going to dig a little deeper into, the mind of Albert Einstein.
Yeah.
And before the break, we were starting to kind of like uncover this
this tension
between him and some of the like core ideas of quantum mechanics.
All right.
Which I got to admit, is a little surprising, right?
Yeah, a little bit.
To think that someone who, like, helped revolutionize physics.
Right. Would later kind of like push back against one of its most significant branches.
Yeah, totally.
So what was it about quantum mechanics that like rubbed Einstein the wrong way?
Well, like we were talking about before the break, quantum mechanics brings in this idea of chance and probability.
Yeah.
Like, it's suggesting that at that, super tiny level, things aren't as predictable and certain as we might think.
Right.
Like, the universe isn't playing by those neat and tidy rules that we experience in our everyday lives.
Okay, I can see how that would be hard for someone like Einstein.
Totally.
Right.
Like, he spent his life searching for those elegant equations, those universal laws.
Yeah.
And now you're saying the universe is like, what, rolling the dice?
Yeah. Yeah, basically.
Yeah, and he was not happy about that.
He famously said, like, God does not play dice.
Exactly, yeah.
Right.
Like, he believed in order, in cause and effect. And quantum mechanics was like
a wrench in the works.
Totally. It challenged his whole belief system.
Oh, wasn't that like kind of an outdated view even at the time?
It was definitely like causing some arguments.
Okay.
You had physicists like Niels Bohr who were saying, no, we got to accept this uncertainty.
Okay.
It's just part of how the universe works.
Okay.
At that level, it's just probability and chance.
Okay. So there was like pushback.
Yeah, there was definitely pushback.
Okay. I'm trying to picture these like intellectual giants duking it out.
Arguing about the universe.
Debating like the very nature of reality.
It must have been intense.
It would have been quite a show.
I know. I would love to have seen those conversations.
Okay. So what were some of the specific things that like...
Yeah. So one of the big ones was quantum entanglement.
Okay. I've heard of this, but I don't really get it.
Okay. So basically it's like, you have these two particles and they're like linked.
Yeah.
No matter how far apart they are.
Right.
And you do something to one and it instantly affects the other.
Right. Like spooky action at a distance.
Yeah, that's exactly what he called it.
Yeah.
And he saw that as like breaking the rules of his own theory.
Oh, so it was contradicting.
Yeah, it was like a contradiction in the universe, Okay,
so he was like, there's got to be something else.
Yeah, he was like, there must be something we're missing.
Right.
Some hidden variable, something that would explain it.
That doesn't break the laws of physics.
Exactly. Without chance and randomness.
Okay. So even though he didn't agree with it, he was still like...
Oh, he was still trying to figure it out. Looking for a deeper answer.
Which I think is really admirable.
Oh, absolutely.
It's not about being right.
It's about the journey.
Yeah.
It's about like... the exploration.
And pushing yourself to understand it better?
Yeah, exactly. Yeah. I mean, that's what science is all about.
Totally.
It's not about like, I'm right, you're wrong.
Yeah.
It's about that constant questioning.
Yeah.
That exploration.
And even though like his ideas weren't ultimately accepted.
Right. But he pushed everyone forward.
He pushed the field forward just by
asking those tough questions.
Yeah.
So
even in disagreeing, he was still like...
He was still making an impact.
Okay, but let's kind of like switch gears again and talk about this other big thing that he was working on at Princeton, which was...
the unified field theory.
That quest for the unified field theory, it sounds so ambitious.
It was a huge ambition.
It's like searching for the holy grail of physics.
Totally.
Right.
It really was, yeah. He was trying to find this one framework to explain all the forces of nature.
Wow. So he was trying to find...
the theory of everything.
The theory of everything.
Yeah, that's what they call it.
Okay, this is where like I really start to like feel my brain like hitting its limits.
It's a big one. Yeah, it's hard to like even picture,
Yeah, it's very abstract.
Even though he didn't find it.
Yeah.
He still laid the groundwork.
He did. He laid the groundwork.
For physicists to like keep searching.
And they're still searching today.
Right. So even his unfinished projects are still shaping the field today.
Planting seeds that keep growing.
It's not just about the answers.
It's about the questions.
It's about like asking the right questions.
Yeah.
Which is like such a bigger legacy than anyone.
Yeah.
It's like discovery, right?
It's about changing how we think.
Yeah. And we can't forget about his influence.
His impact.
Beyond science.
Yeah. Right. Like we were talking about before, like his advocacy.
Right. His activism.
So cheese and all that.
Absolutely. He really understood the connection between science and humanity.
Totally. And speaking of, like,
Yeah.
that connection, right?
Yeah.
Didn't he play a role in alerting the president about the atomic bomb?
Yes, he did.
Like, how did that happen?
Okay, so it's 1939.
Okay.
And he's starting to get really worried about, like, how fast nuclear physics is advancing.
Okay.
And the possibility of the Nazis developing a bomb.
Right.
So he signs this letter with some other physicists.
Okay.
Basically urging President Roosevelt to start a research program into nuclear energy.
So he wasn't directly involved?
Not in the Manhattan Project, no.
Okay.
But he was part of that initial push,
Right, to get it going.
To get it started,
Which, I'm sure later.
I think it really weighed on him.
Yeah. Seeing the devastation of...
Yeah, especially after Hiroshima and Nagasaki.
It must have been, like...
It must have been tough.
Huge burden, right?
Yeah.
And it's kind of a reminder that even, like, the pursuit of knowledge can have these unintended consequences.
Yeah, unintended and sometimes devastating consequences.
Right. So it's like this reminder to be mindful, right?
To be mindful, absolutely.
And to, like, really think about the ethics.
The ethics, 100%.
Of everything.
And to use our voices for good.
Yeah, and to use our voices to make sure that those things are being used for good.
Absolutely.
Okay, so we've covered much quantum mechanics, unified field theory, ethical dilemmas.
Yeah.
But there's still one more piece of the puzzle I want to explore.
What's that?
Which is, like, Einstein's enduring legacy.
His legacy.
Like, how is his work
still shaping our world today?
Well, that's a good question.
Beyond... the textbooks, beyond theoretical physics.
Yeah, how does it actually...
How is it relevant...
touch our lives?
To us in the 21st century?
Yeah, that's a big question.
Yeah.
And that deserves its own conversation.
I have a feeling this is where it gets really interesting.
I think so, too.
I can't wait to, like, unpack all that.
Yeah.
And see how his legacy still lives on.
It's everywhere, you'll see.
But we'll have to pause our deep dive for now.
Okay.
And we'll be back soon to explore... the ripple effects of his ideas.
I can't wait.
And what they mean for us today.
Yeah, it's going to be good.
All right. So welcome back to our deep dive into the world of Albert Einstein.
Yes.
We've talked about a lot, from his like early years and all those groundbreaking discoveries to like his complex relationship with quantum mechanics.
Yeah.
And, all that advocacy for peace.
Right.
But now
I really want to kind of explore this idea that his legacy goes like way beyond the textbooks and the theories.
It's a big one.
It is a big one. And it's like, it's one thing to say, oh, yeah, he was a genius.
Right.
But how does that work actually impact our lives in the 21st century?
That's the fun part, right?
Okay. Yeah. I'm ready.
Okay. So, I mean, you can find like Einstein's fingerprints are all over the place.
Oh, really?
Yeah. His ideas, like, they're not just these abstract theories. They're like, they've actually paved the way for tech.
Okay.
That we use every single day.
Okay. Give me some examples.
Okay. So GPS.
Okay.
I bet you use that all the time, right?
Oh, yeah. All the time.
Those little blue dots that are guiding you, through the streets and stuff.
Right.
That relies on, like, crazy precise timekeeping.
Okay.
From, like, satellites orbiting the Earth.
Yeah.
And here's the thing. Those calculations have to take into account the effects of relativity.
Really?
Special and general relativity.
So Einstein's theories about space and time are literally the reason...
They make GPS work.
GPS works.
Yes.
Oh, my God. That's it's crazy.
It is wild. Like, without those adjustments for relativity, like, those timing signals would be off.
Oh, wow.
And your GPS would be like miles off.
Wow. Okay, so next time I'm trying to find that new restaurant, I got to thank Einstein.
You got to thank Einstein.
For helping me get there.
Exactly.
Wow. Okay, that's a pretty good example.
That's a good one.
I'm starting to see, like, how it's all kind of woven in, right?
Yeah. Okay, what else?
Okay, what about something closer to home, like digital cameras, solar panels. Both rely on the photoelectric effect.
Right.
That's what got him the Nobel Prize, right?
Yeah.
Remember how he's like, light can be a wave and a particle?
A photon. Yeah. So those photons, like in a camera, they hit a sensor. And they release electrons.
Which
create the signals.
Wow.
That form the image.
And
then, like, in a solar panel, those same photons knock those electrons loose.
Yeah.
And that generates electricity.
So he's like not just explaining the universe. He's literally like
Powering our home.
powering our lives.
Yeah.
That's crazy.
It's amazing.
Okay, there's got to be more.
Oh, there's so many. Think about lasers.
Okay.
Like in, barcode scanners,
Yeah.
medical procedures,
Right.
or even like nuclear energy,
Right.
which, is complicated, but
Yeah.
it wouldn't be possible without EMC.
Right.
And like even cosmology,
Right.
black holes,
Yeah.
the universe expanding, all
Yeah.
of that, like
Yeah. It's more than any.
it's a way of thinking.
It's a way of thinking.
Yeah.
This commitment to
Curiosity.
curiosity to like
Yeah.
challenging ideas,
That's what makes him so important.
which is like, I think, more important than ever,
Oh, yeah.
right? In this like ever-changing world.
Totally.
And we can't forget, like, he was part of a community
Oh, yeah, absolutely.
of scientists
Mm-hmm.
building on all this work.
Yeah, like standing on the shoulders of giants.
Right. Inspiring future generations.
Inspiring everyone who came after him.
Yeah, it's all connected.
It is.
So as we
Yeah.
as we kind of wrap up
Yeah.
this whole
deep dive.
yeah, what would you say is like the biggest takeaway?
What do you think?
Like, what can we
From his story,
learn from Einstein?
what can we learn?
That's relevant,
What can we apply to our own lives?
our lives today.
I think it's like never stop questioning.
Oh yeah.
Never stop exploring.
Mhm.
And never lose that curiosity.
Yeah.
Like that, childlike wonder
Yeah.
about the world around you.
Yeah, and don't be afraid.
Not be afraid to challenge what people are saying.
Right, to like go against the grain.
Yeah.
Even if it's hard.
Right. That's how we
That's how breakthroughs happen.
make those breakthroughs,
Yeah,
right?
baby.
And move forward
That's how we all move forward.
as individuals and as a society.
Absolutely.
That was beautifully said.
Thanks.
Yeah, his life really is like a testament
It
to the
is.
power of curiosity and like the beauty of the unknown
Yes.
and like using what we know to make the world better.
100%. Using knowledge for good.
So I think we did a good job,
He did.
of exploring
All those different sides of him.
all those different sides of Einstein's life and work.
Yeah, the equations.
Yeah, from the, the complex equation,
The ethical questions.
to the ethical
Yes,
questions,
impact on the world.
to the, the lasting impact that he's had.
Yeah.
And I hope you've come away from this with
Yeah.
a better understanding of like the man, not just like the
image.
the icon, right?
Right.
And maybe even a little bit inspired
Yeah.
to embrace your own curiosity
Keep asking questions.
and never stop exploring.
That's what he would want.
Yeah.
Yeah.
All right. Thanks for joining us on this
Yeah. Thanks for listening.
amazing journey.
Yeah, it was fun.
And until next time,
Stay curious.
stay curious. Bye. Bye.